The question reads, a cone is made from a sector of a circle of radius 14 cm and angle 90 degree. What is the curved surface area of the cone? Take pi as 22/7. Now this question is testing the knowledge of area of solid shapes, and here a cone is given. So we are asked to find the curved surface area of the cone, and from here we are told that a sector is used to form the cone. A sector is used to form a cone. You can see the sector there, you can see the cone here. Now when a sector is used to form a cone, there are some certain things we must know. Now this is a sector, this is a cone. So when a sector is used to form a cone, we know that the length of an arc of the sector L is equal to the base circumference of the cone. The length of an arc of the sector L is equal to the base circumference of the cone. Likewise, the radius of the sector of the circle here is also equal to the slant height of the cone. The radius of the sector of a circle is equal to the slant height of the cone as given there. Now let's substitute it into this formula. You look and find that the length of an arc is equal to theta over 360 times 2 pi r, while theta is the angle which the arc sustains at the circle, at the center of the circle, and here the value for theta is 90 degrees. Now L here represents the slant height of the cone is equal to the radius of the sector of the circle. Now the formula for curved surface area of a cone is given by the pi RCL. Why RC represents the radius of the cone. You can see there, RC here represents the radius of the cone. Now, if you look into these problems, you find out that in order to substitute variables here in this formula, we are given that pi is 22/7. We know the slant height, which is 14 here, but we don't know the radius of the cone or the radius of the circumference of the cone. So that is the first step to find. And in order to find the radius of the circumference of the cone, we should also know that the length of an arc of the sector is equal to the circumference of the cone. So we are going to find the length of an arc of the sector and now equate it to the circumference of the cone. Then from there we now find out what should be the radius of the circular base of the cone. All right, so let's substitute it there. We find out that substituting that the length of an arc is now equal to 90 over 360 times 2 times 22/7 times 14. If we simplify this, we find out that the length of an arc is equal to 22 centimeter. The length of an arc is equal to 22 centimeter. So, but we need to equate it with the circumference of the cone. And you know the base of the cone is circular. That we can see the shape of a circle. And what is the circumference of a circle is given by 2 pi r. The circumference of a circle is 2 pi r, RC, while r is the radius of the circle. So we are going to find out this RC there. By substituting, we now say that 22, which represents the length of an arc, is equal to 2 times 22/7, which represents pi, times RC, which is what we are looking for. By substituting and simplifying, we find out that RC is equal to 3.5 centimeter, which is equal to the radius of the cone. That is the base of the cone, the radius of the base of the cone. Now we can now use it to solve the problem there, which we say that the curved surface area is pi times radius times slant height. So when I say 22/7 times 3.5, which represents the radius of the cone, times slant height, which represents which is 14 centimeter. So we now have that the curved surface area of the cone is equal to 154 centimeter squared. Centimeter squared because it is area. So it's 154 centimeter squared. Yes.